This is question 14.3.21, and here we are working again with some students who have GMAT scores along with GPAs listed. So we have a number of ordered pairs, actually 8 of them total, and we're actually already given the linear regression equation as well. So we're just asked to determine some information that will be obtained or included in the output of the regression that we run. And you can see here this one is a little bit more normal as far as what we would see in the real world as working with R-squared results and F scores versus p-values, that sort of thing. So with this one here, we can just go right to the regression analysis, data analysis Toolpak, and provide the output that we'll need to answer all these questions. So here we're going to have our Y range, which is our GPA data, that is our dependent variable, and our X range here, it's already selected properly. We have labels set. We're not given an alpha, but it's already defaults in Excel to 0.05. And for our output range here, I'm going to select spot up there, and we'll go ahead and enter, and we can see here first off, just to kind of verify that our output matches the regression equation. You can see here the y-intercept of 1.28 and then the slope here of 0.007. So that does match what we have in our output that we generated. And ask first for the sum of squares total. Remember that the sum of squares total is really just the difference between the value of each dependent variable from our sample minus the average value of the dependent variable from the sample. And we find all those differences and we square them in order to get rid of the effects of the negative values, and add them all up, and that's really what the sum of squares total is. So instead of working with that or other sum of squares formulas, manual formulas, it's so much quicker and easier, more efficient to just get that information from Excel. And we have that here. You can see the 3 different variables that we need for the problem: sum of squares regression, sum of squares residual, and those combine to equal the sum of squares total. So that matches what we have in our solution boxes. Our R squared up here, 0.428, matches as well. And next question, part D, is asked about the null and alternative hypotheses for doing a hypothesis test for the coefficient determination to test that the population coefficient is actually greater than 0, meaning that there is a relationship between the independent variable and the dependent variable. So independent variable again being the GMAT scores, the dependent variables being the GPAs of the students. So in this case, we're working with the F distribution, which is a right-skewed upper tail distribution. So our alternative hypothesis is going to be that the population coefficient is going to be greater than 0. So that's what we're really testing for. The F score for the test is given with our output here. So we've got our F score with our ANOVA output, and we also have the p-value as well. So this saves us from having to use even Excel functions, certainly having to use the manual formula that you'll see in your textbook for the F test statistic. So much faster to do it this way. And if we did want to base our decision or basically state our decision regarding the accept or rejecting of the null with the critical value, we could do that. We see that with our p-value, it is 0.08, which is higher than, or 0.078, which is higher than the assumed alpha of 0.05. So we would reject the null based off of the p-value. But we could also, not really necessary, again, just to show you, we could also use the critical value approach as well by just calculating the F critical value, which we would use the f.inv.rt function. Our probability is the alpha. And our degrees of freedom are d sub 1 is 1, since it's a simple linear regression, just one independent variable. And degrees of freedom, d sub 2 is the number of ordered pairs minus 2. So that gives us a critical value of almost 6, which is higher than the f-test statistic. So being that the statistic here for the f-test is lower than the critical value, we would reject the null with that approach as well. Use XLStat as well to perform the regression, and I'll show you that here as well. Modeling data, and we go to linear regression and back onto the correct column there. So our dependent variable, we'll select that range. And same thing for our dependent variable. And we're going to have the output go onto a separate sheet. And we have our default alpha or confidence interval of 0.95, alpha of 0.05. Our output is just going to be the ANOVA table. And we're going to click OK. All right, and we can see here, just to kind of confirm, we have the linear regression data here, the intercept of 1.28 and the slope of 0.007. And we have our R squared of 0.428 there. We have our p-value of 0.078, shows up here as well in the ANOVA table. And then our f-test statistic also at 0.450 rounded. So that's how we can use XLStat to get the same information as well. And you'll see actually down here, it actually provides the linear regression equation for us as well.